Good morning, students. Today I will take a new topic, that is valence bond theory. You see, in the case of the covalent bond, when two atoms they combine together by sharing of the electrons, they form the covalent bond. But simply covalent bond formation means molecule is formed, but it does not explain many theoretical properties. That is, what is the force of attraction between the two atoms, what is bond length, what is bond dissociation enthalpy, and other properties. So to explain all these things, two important theories based upon quantum mechanical principle were given. One is valence bond theory and other is molecular orbital theory. Today I will explain you valence bond theory. See, valence bond theory, it is based upon the atomic orbital and the electronic configuration of the atoms. To explain the valence bond theory, some assumptions are there. That is, atoms do not lose their identity during the formation of the molecules, but the valence electrons, they lose their identity. Listen, atoms do not lose their identity, only the valence electron they lose their identity. Bond is formed due to the interaction of the valence electron, and the stability of the bond is due to release in energy. That is, molecules require some minimum energy for the stabilization at a certain distance between the atoms. It is known as the internuclear distance. So these are the assumptions for the valence bond theory. Now this thing we can explain by taking the valence bond in the case of the hydrogen molecule. You see, it's very important and the interesting. When the two hydrogen atoms they are far away from each other, there is no force of attraction, and the total amount of the energy will be equal to the sum of the energy of the both atoms. Now when the atoms they come close to each other, what happens? It's very interesting. Listen, two atoms, suppose Ha and Hb atoms. Ha atom has A electron and the Hb atom has the B electron. Now when they come close to each other, what will happen? Attractive forces they will be created. One force of attraction is already there, that is nucleus of H atom to the electron of the A, and the force of attraction of the B atom nucleus to the B electron. Now the other force of attraction between the B atom nucleus to the A electron. In the same way, force of attraction of A hydrogen atom to the B electron. So there are two types of the attractive forces, that is when they come close to each other. Now what happened? Two opposite atoms and the two opposite electrons, they have the same charge, that is nucleus of the A and the nucleus of the B, they will repel each other. And in the same way, electrons of A and B having the same charge, they will repel to each other. So we say there are two attractive forces and the two repulsive forces. Now it's very important how the atoms they come close to each other to form molecules. When two types of the forces are there, if attractive forces are more than the repulsive forces, then the atom they will come closer to each other. And if the repulsive forces are more than attractive forces, they will go far away from each other. So, when attractive forces they balance the repulsive forces. Listen, attractive forces they balancing the repulsive forces. So, new attractive force is more than the repulsive force, and the potential energy decreases. It means when the attractive forces they balance the repulsive force are more than the repulsive force, energy will decrease. That is, the potential energy will decrease, and the molecules they will come closer to each other to form the stable molecules. Listen, when the attractive forces they are the repulsive forces, when the attractive forces more than the repulsive forces are attractive forces, they balance the repulsive forces. The repulsive forces and potential energy at this stage decreases and the molecules become more stable. The force of attraction balance the force of repulsion at the minimum energy. So we say that a minimum energy is required for the molecule formation takes place. And in the case of the hydrogen, listen one point more. If repulsive forces are more than the attractive forces, there will be no molecule formation, or we said that the molecule will not be stable. So for a minimum energy is required for the stabilization of the molecule, and at this stage bond length, that is, there will be a minimum bond length. In the case of the hydrogen, it is 74 picometer. That is internuclear distance. So the point is that whenever two atoms they come close to each other, two types of the forces are there. One is attractive force, other is repulsive force. When the attractive force will be more than the repulsive force, or when the attractive force balance the repulsive force, molecules they come closer to each other and there is loss of energy, that is potential energy decreases, and the minimum energy, at a minimum energy the molecule become more stable. At this stage it was found that the minimum energy or the minimum distance for the stability of the molecule in the case of the hydrogen is 24 picometer. So today I will explain you bond theory, that is valence bond theory. In my next video I will explain you molecular orbital theory. So it's very important and interesting how the molecule formation takes place. So simply two types of the forces are there, attractive forces and the repulsive forces. When the attractive forces they are more than the repulsive forces, then the atoms they come closer to each other and form molecules. Okay, so if you like my videos, please share and subscribe. Thanks very much.